an animation. It's not real. We've never taken a picture of a black hole. It's important that people know that. Well, not, okay, we'll get there. Nobody's ever released the press report.
No, that's certainly true.
Direct image.
Which they will any minute now. But so this was a visualization of the black hole basically casting a shadow. I mean, that's effectively what it does, right? It casts a shadow on the sky because any light that comes near it falls in. And why does it look so smeary, Priya, like this?
Right, so, when you think about the fate of light rays that graze close to sort of the sacred boundary of the event horizon, what happens is that some of these light rays that will cross basically are lost. There are some that are going to skirt and they're sort of going to be in Dante's limbo forever, right? And that's sort of the photon ring, so that's sort of what you see. And then there's stuff, because of the intense bending of light, because the shape of space is so dramatically modified right around the black hole that you can see, if you will, the back of your head. So you see the sort of smearing when you see the sort of the top where you see
So if you were standing at the right location and you had a flashlight, and the light from the flashlight took an orbit, it could bounce off the back of your head and come back to your eyes, and you'd look at the back of your head. I've always wanted to get a better image of my hair. Like aligning the mirrors.
Sounds a little complicated, right?
I could use it as a method to like check my hair before going on stage.
Yeah, it is a way to see things behind you. Like actually that outer circle that you see, it's called the Einstein Ring. It's made up of light that's entirely behind the black hole, and it's what we call gravitationally lensed, basically bent towards you. I mean, like the back of your head. So
yeah. Well, you can't hide behind a black hole. If you're hiding behind a black hole,
you can't hide behind
gets lensed around. So yeah, I always say this, if you're like in a space battle, like don't try to hide behind the black hole. It's like it's not a good spot. So I actually have, this is different than a cartoony animation. This is actually a mathematical model by Andrew Hamilton, who's a physicist in Colorado. So it's a completely mathematical simulation of what it would be like if you were an astronaut and you were orbiting a black hole. And so the reason why the ring is swirling is really because of your own orbit, right? So you're seeing our own galaxy behind the black hole being lensed. Now we were talking about it as an object, and I kind of wanted to take issue with that. So Fariel, you said it's a very dense object, but right here at the event horizon, there's nothing.
Right. I mean, so
it's actually empty.
So that's what it's a singularity.
Well,
but,
not
but
yet.
I didn't want to start with, it's an infinite singularity. No. So, yeah, technically that's true. It doesn't have a surface. It's not really an object the way we know other objects.
Yeah, so if you walked into the shadow of the event horizon, what would you experience?
Actually, not much.
Not much.
So the tidal force would bother you, but otherwise you're just falling in. I mean,
no one can hear you scream. No, well, not even light can escape, right?
Exactly.
So there you are.
Yeah. And yeah, no one can see if your hair is being torn apart either, so you'll be fine.
Good.
Yeah. So
I'll have one consolation. Yeah,
right.
As I fall in.
Exactly.
So also time would slow down, right? For you, time would slow down.
But you wouldn't experience.
You wouldn't experience it, but your friend, your poor friend who was waiting outside for you.
So Priya, are waiting for me for coffee somewhere back at the Earth, and I'm falling through the event horizon. It could be like several million years. Before.
Yeah, we would think that not much is happening to you. You're kind of frozen in that horizon, and you're like, what are you talking about? I'm going straight in.
And you're going really fast. You're evolving really quickly.
Yeah.
So these are two myths that I love to dispel. One is that black holes are objects. They're actually nothing. They're sort of regions of space. They're places as much as anything. And also that, black holes are dark. They're only dark from the outside.
That's right.
They can be very bright on the inside. So how does that happen?
Well, I mean, this simulation actually shows that, right? I mean, you're starting to see light coming from all areas, all directions of the black hole here.
Mm-hmm. Yeah, so you're inside the black hole. This, I think, astronaut in this simulation is already inside the black hole. And so they're collecting light from the whole galaxy. So for them, it's remarkably bright for the microsecond they have to live. So the only thing we do know for sure is like death by black hole is assured, right?
Absolutely.
Right, exactly.